BGP Community, double M, BGP Community. You see, community is nothing but grouping, right? Grouping, community attribute. So if you have some common for a network, common thing for a network, you tag it with a value so that it can be identified in a group. Let me make it very easy for you now. You see, there are a lot of flowers in the garden. A lot of flowers in a garden, different colors and lot of flowers. Let's take like 4-color garden. You know, you have a garden and you got green color flowers, just for example. Okay, I have never seen green color flowers. Blue color flowers, orange color flowers, and then pink color flowers. So you have colorful garden. You see, it is already community. Green is what? A community. All the plants inside that rectangle are identified as green plants. Actually, all are plants. Blue plant is also a plant. In the garden, we have a lot of plants. But not all of them are of same community. Some belong to orange community, some belong to green community, some belong to blue community, but all are plants. So you have a nice color to identify, nice tag. The green is what? Green is a tag to identify. Blue is another tag. Orange is another tag. Pink is another tag. These are all tags to identify those plants. When I say pink plant, your eye go to the right down. You focus on this only. When I say pink, you don't see here. You don't see here. So when I say pink, you see your eyes go here. When I say blue, your eyes go here. When I say green, your eyes are still not in blue, your eyes immediately moves here because they're all tagged, colored. BGP community is also like color only, a tag. Instead of orange, green, blue, we tag it with a number. We tag it with some number. BGP community is a number. The number identifies prefix. That number identifies a service need to be provided to a prefix. It need not to be always prefix. It's a service to the prefix. For example, all the green flowered plants, send it to Africa. The deserts of Africa, let it become green. So send all the green flowered plants to Africa. See, I'm using the tag value. Will the green plant be sent to London? No. It will be sent to Africa. Take all the blue plants and send to Germany. See, I'm using the tag value to identify the group and to provide service. What service? Sending to Germany is a service. Sending to Africa is another service. Any flower matches green will not be sent to Germany, it will be sent only to Africa. So the green means Africa. Blue means Germany. Pink or the orange means Israel. Israel. Orange. Send all the orange flowers to London. So there's a function behind the tags. Orange means sending it to Israel. Green means sending it to Africa. Blue means sending it to Germany. Pink does not mean send to Africa. It says the service need to be what? Sending to London is the service. So because of this color, you are able to provide different services. Likewise, in networking, here is a customer. Here is a provider. There is an EBGP between this customer and the provider. Customer has got various networks inside, let's say 1.1.1.1, 1.1.1.2.1, 1.1.3.1, like many networks inside his organization. This is customer edge router and this is provider edge router. Now this customer is reaching the internet via ISP. Right? ISP is the way via which customer reaches different part of the world. Some may be going to autonomous system 10, some may be going to autonomous system 20, some autonomous system 30. But to go to any destination, we have various services. Service provider can provide you MPLS, so it is a mesh network inside the service provider network. So ISP may provide you a MPLS connection. He may provide you a IPsec connection. He may provide you, he is ready to provide you IP services. This is IPsec. Meaning anything that it goes inside, any traffic you put inside this will be labeled switched, MPLS. Any packet that you put inside this yellow will be encrypted, IPsec. Any packet that is put inside this orange will be normal routing, IP routing. So we got various services on the service provider side. But the customer has got a condition. If any traffic that is coming from this one needs MPLS. If any traffic comes from 113 needs IPsec. If any traffic comes from this orange, where is orange? If any traffic comes from this, needs simple IP routing. You see, customer has got this constraint, this policy. What? If traffic is coming from blue, needs to use MPLS. If it is coming from orange, needs to use IP routing. That tunnel. In the service provider side, this traffic should go via this one. If it comes from blue, it should go via MPLS. If it comes from yellow, it should go via IPsec. Encrypted. This is what expectation from the customer side. But how ISP knows that if traffic is coming from this, I need to send via that? So what we do is we ask the customer. See, on the service provider side, we have this color. What color? Color here, orange means, why different color is coming? Okay, yellow. Orange means, yellow means IPsec. And orange means IP. Blue means MPLS. They have already predetermined this. Now these colors we have to give to the customer. Customer, take this. Now customer is given with this color, and customer is told that if you want to send any traffic via MPLS, use blue. Then immediately he colors with blue this one. Why? He wants to send these flowers to the MPLS tunnel. So he colors this network with blue color because he wants MPLS. And you said customer, if you want to send through IPsec, use orange. Then immediately you mark it with IPsec, because any traffic going from here, you want to send through IPsec tunnel. Customer, if you want to send through IP path, normal IP path, color it with yellow. Then you immediately color it with yellow. Now the traffic goes with yellow color. The PE router knows, okay, yellow means I need to send via IPsec. Now a traffic is coming with the color orange. Okay, orange means I need to send via IP. Now the traffic from the customer is coming with the color blue. Okay, blue color I'll send through MPLS. You see, color matters. With the color only, ISP now knows via which path or which service I have to provide for this traffic. As I said earlier, instead of color, what we use? Number. For your understanding, I put this color. Let's say blue is equal to 100:100. This is how we color it. 100:100 means it should go via IP path. If it is 101:100 means it should go via normal IP. Blue is MPLS. This is normal IP. Next, 200:200 means IPsec. So these numbers When a packet goes with 100:100, ISP knows that I need to send via MPLS. Because who decided this color? Service provider. Service provider only decided this color. Service provider says, we will give customer 100:100 if they want to send it via MPLS. Let us give the customer 200:200 if they want to send any traffic via IPsec. Let us give the customer 101:100 if they want to send via IP. So ISP determines this color, this number, and they provide that number to the customer. So customer put that number, they put the tag value, and they send it to the provider, and provider now knows via which tunnel he has to push the packet. So I can set weight now. If blue is matched, high weightage to the neighbor, only then I can go through MPLS. High weightage to this neighbor. I set weight attribute. So it will go via that neighbor. If it is orange, I give a high weightage to this IP path. If it is yellow, means if it is 200:200, I set high weightage to this neighbor. So when a traffic arrives, automatically it goes in that direction. If it is yellow, it goes via the middle router. If it is blue, it goes via the upper router. If it is orange, it goes via the down router. When it takes the down router, automatically IPsec encryption will start happening, because IPsec is enabled on that link. So whatever I have delivered now, it's a user-defined community value. User-defined community value. There is also predefined community value. Let's see that one. There is a community called local AS. There is a community called internet. There is a community called, okay, first let me explain what is local AS. If you have configuration, we need this. So if any network is attached with a community local AS, they will be advertised only within configuration, which is private AS. If I say internet, it is advertised to all routers, all EBGP, IBGP routers. There is also something called no advertise. It won't advertise to EBGP, it will advertise only to IBGP. So likewise, there are well-known communities. These are all called as well-known communities. Well-known communities, custom communities. These are all custom communities. ISP decides the meaning to the number. They share the number to the customer, and customer uses the number, and when the packet comes to ISP, ISP provides the service as per the number, as per the tag value. So let's see some more well-known attribute. I think one or two is missing. So what is BGP community? BGP community is a bit of extra information that we can add to one or more prefix. Sorry, I want to zoom it. So BGP community is an extra information that you can add to one or more prefix. This extra information is advertised to the neighbor. So neighbor gives the meaning for that extra information. Extra information can be used for things like traffic engineering, dynamic routing policy. I gave you an example. I want to send through IP signal. I want to send through MPLS term, like that. So community is nothing but coloring, tagging. Tags using numerical value. There are also 4 well-known communities. Internet, I said. Internet. This community is you need to simply put internet. Automatically it will assign a numerical value, predefined. So when the receiving router receives with a predefined numerical value, it knows that I need to advertise to all neighbor. All neighbor. Local AS I covered. Do not advertise prefix outside the sub-autonomous system. What is sub-autonomous system? Private autonomous confederation. Next is no export. Don't send to EBGP. Don't advertise to EBGP, meaning you should advertise only to IBGP, only within IBGP. There is also another called no advertise. Don't advertise to anyone. IBGP or EBGP. Don't advertise to anyone. Well-known communities. Internet. No advertise means don't advertise to anyone. Internet means you can advertise to anyone. Internal or external, you can advertise to anyone. No problem. No advertise, you cannot advertise to anyone. Opposite, you cannot, that is can. Internet is can. No advertise is cannot to any neighbor. Next is no export. Don't advertise the prefix to any EBGP neighbor only. So you have no problem in advertising to IBGP neighbor. Next is local AS. Don't advertise the prefix outside the sub-autonomous system. Why do we call them community? Community is a group of prefix that should treat the same way. I told you, flowers, all green flowers. Group of prefixes. Group of network that you want to give a common service. For example, maybe you have 100 prefix that requires same local preference. 100 prefix that needs to go via MPLS tunnel. So you use local preference or wait for those 100 prefix. So if you have 100 prefix that needs same local preference, you should match all the prefix using an access list or a prefix list. But using community is more convenient than writing access list and prefix list. That is why we use community. You can also do it through access list and prefix list. But best way is using community. In BGP you have this flexibility of using community. So instead of manually selecting the prefixes, an ISP could instruct its customers to tag the prefix. I told you, ISP only decides the tag value, the color, the community number, provides the customer. Customer only attaches the tag value. So when ISP receives with the tag, they know what treatment, what special service to provide. To give you an idea, here are some of the examples that level 3. Anything that tagged like this, prepend once to all peer. Anything that tagged with this, prepend once to peering with only those AS number that is. Don't worry, this is too much. This is from on production. Better example will be here. Configuration example. Right, you can go through this. I'll send you this document immediately after this class, and we will do a lab on all this. Advertise, no expert. Right, at last we will do another lab here, this one, BGP Community Lab, in page number 55. Right, so what we have learned is, we'll do the lab in the next class, not today. What we have learned is BGP Community. BGP Community is nothing but a numerical value that we use as a tag value to identify a group of prefixes so that you can get some special service from the service provider side. Service provider will provide you the number to identify. We attach the number and send it to the service provider from the customer. It goes to the service provider with the tag. When service provider receives with the tag, they know what service to provide, like local preference, MED. I gave you some better examples, sending via IPsec path, sending via MPLS path, but to achieve that, what you use in BGP is local preference, wait, things like that. Right, so this is not a mandatory attribute. Community is an optional. Only when you enable community, it is going to be there, and it is not only optional, it is transitive. This community value is advertised from the customer to the provider, and provider uses the tag value which came as an advertisement to provide you a specific service. So it's an optional transitive attribute. Community is an optional transitive attribute. Any question? Please ask question from community.
Well, I didn't understand the configuration for global AS.
Configuration is totally different topic. It's not related to this, but anyway, what is configuration? Creating sub-autonomous system inside one autonomous system. Why? To avoid full mesh. To avoid full mesh, what we do? We create route reflector. But how many route reflector you can give? If I have 100 router, will you do route reflector after every one router? Every alternate router? Not possible. So what they do is, configuration is creating private autonomous. See, this is not right now in usage. That's why I did not focus much on configuration. But I am explaining because you asked the question. See, there is one big autonomous system with many routers. Are you going to create route reflector here one so that this will be advertised? Again, route reflector here so that this will be advertised? No, not possible. You cannot create that many route reflector. What they do is, this is one RR, this is one RR, this is one RR, and then this actual autonomous system number is 10. But inside they create small autonomous systems like 65511, 65512, 65513. This is called configuration. This is called sub-autonomous system, so that these two will think I am an eBGP. Split horizon cannot stop now. Route learned from an IBGP should not be given to another IBGP, so you have RR. These two are what relationship? eBGP. Even though the main autonomous system is 10, the sub-autonomous system number is different. This is what called as configuration. So this router will definitely give the routes to this one because they have eBGP 12 and 13. And it will come here and this will reflect. You understand what is configuration?
So when it will advertise to other A's, So it will advertise not 65112 or 13, it will advertise AS10.
When it advertises to autonomous system 20, it will advertise as AS10 only. It will suppress all this sub-autonomous system.
So AS20 cannot understand, whether it is initiated from 655.
No, it will not know. It will not know. It is local. It is called private autonomous system. This is what called as confederation. So when you say allow local, it is going to be local between the sub-autonomous system. It won't go outside. Any other question? Why you don't need confederation today? In today's world, we will not need confederation because we will have always MPLS tunnel between these two routes. We will not be running in first place BGP in every route. We will have MPLS. Because you have MPLS, you no need confederation.
Sir, could I get a brief topic about MPLS? Because I haven't really heard about that.
Don't worry about that. That's going to be our next topic.
Okay.
After BGP is MPLS. Alright, we'll stop here. We'll continue this community tomorrow. Tomorrow is going to be lab day for community. Take care. See you. Bye-bye.